So today is 1 hour class, like one extra class we are going to solve it today. Okay, so we will solve the last week problems, some of the problems, and next tomorrow we will solve the remaining problems for 2 hours. So tomorrow will be the last class for this course. It will be winding up class. Okay. So let us start the first question. Consider a parallel plate capacitor having an area of 6.5 into 10 to the power minus 4 meter square and a plate separation of 2 into 10 to the power minus 3 meter, across which a potential of 10 volt is applied. If a material having a dielectric constant of 6 is positioned within the region between the plates, and compute the polarization. Okay, so options are given. Options I am not reading. Okay, so here, so what are the parameter? Permittivity, epsilon of the dielectric medium. So epsilon, that we know the formula, epsilon 0 epsilon r. So the value like 8.85 into 10 to the power minus 6 into 6 f by m. So you will get the answer 5.31 into 10 to the power minus 11 Faraday per meter. Okay, now the polarization. So polarization, it will be P is equal to D minus epsilon 0 E. Okay, so it will be epsilon E minus epsilon 0 E, so that we can write as epsilon V by D minus epsilon 0 V by D. Okay, now we know that the question D is equal to 2 into 10 to the power minus 3 meter and V is equal to 10 volt. Okay, then polarization P, it will be 5.31 into 10 to the power minus 11 into 10 divided by 2 into 10 to the power minus 3 minus then it will be 8.85 into 10 to the power minus 12 into 10 divided by 2 into 10 to the power minus 3. So you have to find the answer. So just try and let me know which answer will be the correct in this. So here option C will be correct. You just substitute once again. Okay. So you will get the answer 2.21 into 10 to the power minus 7 coulomb per meter square. Okay, check it once.
Okay, madam.
Yeah. So just note down. We'll go to the next problem. So the second problem, the polarization P of a dielectric material positioned within the parallel plate capacitor is to be 4 into 10 to the power minus 6 coulomb per meter square. If an electric field of 10 to the power 5 volt per meter is applied, what will be the dielectric displacement D? Okay, so the polarization P, that is epsilon 0 into epsilon r minus 1 E. Okay, so epsilon r minus 1, that is equal to P by epsilon 0 E. So it will be 4 into 10 to the power minus 6 divided by 8.85 into 10 to the power minus 12 into 10 to the power 5. Okay, so the dielectric constant epsilon r, it is 4.52 plus 1, that is equal to 5.52. Okay, now the permittivity of the dielectric material, so that will be epsilon is equal to epsilon 0 epsilon r. So it will be 8.85 into 10 to the power minus 12 into 5.52. So it will be 4.88 into 10 to the power minus 11 Faraday per meter. Now electric displacement. So electric displacement D is equal to epsilon E. Okay, so substitute all the values. Epsilon is 4.88 into 10 to the power minus 11 into 10 to the power 5 coulomb per meter square. So find the answer for it and check it which one will be in the option. So here the answer will be 4.88 into 10 to the power minus 6. Okay, so option A will be the correct answer. Okay, now let us go to the third one. For CaO, the ionic radii for Ca2 plus and oxygen 2 minus ions are 0.100 and 0.140 nanometer respectively. If an externally applied electric field produces a 5% expansion of the lattice, compute the dipole moment for each Ca2 plus and O2 minus pair. Okay, assume that this material has completely unpolarized in the absence of the electric field. Okay. So first the interatomic separation, that D will be how much? 0.100 plus 0.140 nanometer, right? So it will be like 0.240 nanometer. Now increase the length of the separation. So increase length of the separation, we can take it as delta x. Okay, so it's 5%. So 0.240 into 5 divided by 100. Okay, so it will be 0.012 into 10 to the power minus 9 meter. Now dipole moment for each Ca2 plus O2 minus pair will be what? Pair is mu, that is equal to delta x into 2e. Right. So it will be 0.012 into 10 to the power minus 9 into 2 into electronic charge 1.6 into 10 to the power minus 9, 19 coulometer. Okay, that will be the answer for this. So check it which option is coming correct. So here the answer will be 3.84 into 10 to the power minus 30 kilometer. Okay, so now we will go to the next problem. So a charge of 2 into 10 to the power minus 10 coulomb is to be stored on each plate of a parallel plate capacitor having an area of 650 millimeter square and a parallel plate separation of 4 millimeter. So if a material having a dielectric constant of 3 into 3.5 is positioned within the plate, then they calculate the dielectric displacement D. Okay, so here you have to calculate the dielectric displacement. So first let us write what are the parameters given. Charge Q, that will be 2 into 10 to the power minus 10 coulomb. Okay, and then plate area A, that is equal to 650 into 10 to the power minus 6 meter square. Okay, now plate separation D, that is given 4 into 10 to the power minus 3 meter. Okay, now capacitance we have to calculate. So capacitance C, we know the formula already, epsilon 0 epsilon R A divided by D. So substitute all the values. So it will be 8.85 into 10 to the power minus 12 into epsilon R value 3.5 and area, that is 650 into 10 to the power minus 6 whole divided by 4 into 10 to the power minus 3. Okay, so you will get the answer 5 into 10 to the power minus 12 farad. Okay, now you have to calculate the voltage across the capacitor. V is equal to Q by C. So it will be 2 into 10 to the power minus 10 divided by 5 into 10 to the power minus 12. So it will be 40 volt. Okay, now the displacement will be dielectric displacement D will be epsilon 0 epsilon R into E. So it will be epsilon 0 epsilon R V by D. So that answer will be 8.85 into 10 to the power minus 12 into 3.5 into 4 divided by 4 into 10 to the power minus 3. So just find the, substitute all the values and multiply it and find the answer. Okay, then let me know which option will be the correct one. So just check it. Here you might have got the answer 3.09 into 10 to the power minus 7 coulomb per meter square. So that option will be B. That will be the correct answer. Just note down, then we will move to the fifth problem. Okay, now let us move to the fifth problem. If all the molecular dipoles in a spherical water drop having radius 1 centimeter are pointed in the same direction, calculate the intensity of the polarization, and the dipole moment of the each water molecule is 5 into 10 to the power minus 30 centimeter kilometer. Okay, so here also options are given. So first we have to calculate the volume of the water drop, so that it will be V is equal to 1 by 3 pi into 10 to the power minus 2 whole cube. Okay, so it will be 4 by 3 pi into 10 to the power minus 6 meter cube. Okay, now mass of the water drops, m, we have to calculate. So 4 by 3 pi into 10 to the power minus 6 into 10 to the power 3 kilogram. So it will be 4 by 3 pi into 10 to the power minus 3. Okay. Now number of the water molecule contained in the water drop, that is capital N, we can write it. So it will be 6.023 into 10 to the power 23 divided by 18 into 10 to the power minus 3 into 4 by 3 pi into 10 to the power minus 3. So you will get the answer 1.4 into 10 to the power 23 molecules per meter cube. Okay, now intensity of the polarization, capital P, that will be N into mu E, that you can write it as 1.4 into 10 to the power 23 into mu E value 5 into 10 to the power minus 30. So find the answer for this and let me know which one will be the correct option. Then we will go to the next problem. Okay. So what are the simple questions? You have to just go through the formulas once. That's it. So here what is the answer we got for the 7 into 10 to the power minus 7 coulomb per meter square. That is option B will be the correct answer. Okay. Now let us move to the sixth problem. The relative permittivity, the relative permeability of argon at 0 degree Celsius and and 1 atmosphere is 1.00044. Okay, so calculate the atomic polarizability of the argon atom. So this also simple question. So first you have to know that STP condition, the number of argon atom contained per cubic meter, that we are calling as N. Okay, so N will be 6.023 into 10 to the power 23 divided by 22.4 into 10 to the power minus 3 per meter cube. Okay, so you'll get the answer here 2.7 into 10 to the power 25 per meter cube. Okay, now the argon polarization P, it will be epsilon 0 into epsilon r minus 1 into E, that is equal to N alpha E. Okay, now alpha E we can write it as epsilon 0 into epsilon r minus 1 divided by N. So it will be 8.85 into 10 to the power minus 12 into 1.00044 minus 1 divided by 2.7 into 10 to the power 25 farad per meter square. Okay, so you will get the answer 1.44 into 10 to the power minus 40 farad per meter square. Just go through it and note down, then we will move to the next problem here. Hope you noted it. Now let us go to the 7th problem. Okay. So the dielectric constant of a helium measured at 0 degrees Celsius and 1 atmosphere is 1.0007. So under these conditions, at the gas contain 2.7 into 10 to the power 24 atom per meter cube at the radius. So the radius of the electron cloud, that is atomic radius, is 5.9 into 10 to the power minus 11 meter. Calculate the displacement x when a helium atom is subjected to a electric field of 10 to the power 6 volume 10 to the power 6 volt per meter. Okay, now for the displacement, that value x, it will be 4 pi epsilon 0 r cube e divided by z e. Okay, so r we know that 5.9 into 10 to the power minus 11 meter, and e will be 10 to the power 6 volt per meter. Now x value, just we have to substitute all the things when things are constant. So 4 into 3.14 into 8.85 into 10 to the power minus 12 into 5.9 times 10 to the power minus 11 whole cube times 10 to the power 6 divided by z value, that is 2 into 1.6 into 10 to the power minus 16. Minus 19. So that is the electronic charge. Okay, so substitute all, means apply all these values there and let me know what is the answer you are getting. This is just direct formula you have to remember, but this formula is very important. Okay. So here you will get the answer 7.13 into 10 to the power minus 17 meter. So that will be the option C. Okay. Now let us go to the 8th problem. If all the atoms of a diamond are polarized alike and produces a polarization density of 1.32 into 10 to the power minus 5 coulomb per meter square, calculate the shift of the center of negative cloud of 6 electrons on each atom from the nucleus. So given the density of the carbon is 3500 kilogram per meter cube, atomic weight of carbon is 12 gram per mole, and the Avogadro number is 6.023 into 10 to the power 10 to the power 23. Okay, now so the number of carbon atom contained per cubic meter, that is n value. So n value will be rho Na divided by Ma. Right, so it will be 3500 into 6.023 into 10 to the power 23 divided by 12 into 10 to the power minus 3. Okay, so that answer you will get it 1.76 into 10 to the power 29 per meter cube. So that will be the n value. So now the density of the polarization, that is P is equal to n mu E, and the electric dipole moment mu E will be P by n. So from there we can write mu is equal to P by n. Okay, now so we have to calculate the mu E value. So 1.32 into 10 to the power minus 5 divided by 1.76 into 10 to the power 29 coulomb meter. So you will get the answer 7.5 into 10 to the power minus 35. Okay, now there is a shift of negative cloud, that is x, you can take it as. So then mu E will be ZEX, right? So from there you have to calculate the x value. So it will be mu E divided by ZE. So it will be 7.5 into 10 to the power minus 35 divided by 6 into 1.6 into 10 to the power minus 19. So it will be 7.8 into 10 to the power minus 17 meter. So that will be the answer, option C. Okay. So please note down, then we will go to the next one. Okay, now we'll go to the ninth problem. So calculate the critical current for 1 millimeter diameter wire of lead at 7 Kelvin. So a parabolic dependence of the parabolic dependence of H upon T may be assumed. Okay, so given Tc for lead is 7.2 Kelvin and H0 value that will be H0 value of lead is 7 into 10 to the power 4. Okay, so H0 value that is given, that is equal to 7 into 10 to the power 4, and Tc value it is given 7.2 Kelvin and T value it is given 7 Kelvin. So critical magnetic field Hc value at T is equal to 7 Kelvin, that is equal to H0 into 1 minus, this we have solved in last class also, T divided by Tc whole square. Okay, substitute all the values, 7 into 10 to the power 4 into 1 minus 7 divided by 7.2 whole square. Okay, so you will get the value 3834 into 3834.88 ampere per meter. Okay, now the critical current IC value it will be 2 pi r into Hc. So it will be 2 into pi into r will be 10 to the power minus 3 divided by 2 into 3834.88. So you'll get the answer 12 ampere. Okay, so option 4 will be the answer here. So the fourth one. So
Madam, please repeat last relation.
oh, that this one, that current I
Last
will
two, sir.
this one, right here, this current I will be is equal to 2 pi r into Hc.
Okay.
we'll go to the last problem today. A superconducting tin has a critical temperature Tc, that is 3.7 Kelvin, is in zero magnetic field, and a critical magnetic induction B0 is equal to 0.030 Tesla at 0 Kelvin. Okay, find the critical field at 2 Kelvin. So here Tc value, that is given 3.7 Kelvin. Okay, B0 value 0.0306 Tesla. Okay, and H0 value will be B0 divided by mu 0. So it will be 0.0306 divided by 4 pi into 10 to the power minus 7. So that answer will be 2.43 into 10 to the power 4 ampere per meter. Now T temperature, that is equal to 2 Kelvin, you have to calculate the Hc value. So the formula we know already, H0 into 1 minus T divided by Tc whole square, right? So substitute all the values here, 2.43 into 10 to the power 4 into 1 minus 2 divided by 3.7 whole square. Okay, so you will get the answer 1.72 into 10 to the power 4 ampere per meter. So option A will be the correct answer. Okay, so these are the problems. So tomorrow will be the last class for this course. Okay.
Okay, madam.
Yeah. So see you tomorrow. Bye.
Okay, okay. Thank you.